Let's go. Hey.
I'm so heated right now. Heat really does exist.
You can stand under my umbrella. You can stand under my umbrella.
Boy, and see is my friend, Roby G.
They see me mowing my front lawn. I know they're all thinking I'm so wide and nerdy.
Hello class, I'm Little Will. For the opener today, we're going to talk about potential energy. Do I have potential energy?
Eyeballs, class. Eyeballs, you need to listen to this. This is on your test. Eyeballs. Christian, eyeballs. Christian. Taylor, eyeballs. This is on your test.
Today we'll be showing that mechanical energy is not conserved in real life situations. We've created a real physical problem where we have a point 1, 2, and 3 using Hot Wheels tracks. We'll start up here at point 1, and then we will use our Hot Wheels car and then conduct a problem as we have done in class previous times. At point 1, the velocity is 0 meters per second, meaning there's no kinetic energy. The height is 0.762 meters. At point 2, there is potential and kinetic energy. There is potential energy because the height is 0.1905 meters, which is less than our first height of 0.762 meters. At point 3, there is no potential energy because there's a height of 0 meters, but there is kinetic energy because it is lower than the first two hills at point 1 and point 2.
Mechanical energy at point 1 equals mechanical energy at point 2. Mechanical energy equals PE plus KE, and mechanical energy equals PE plus KE. At point 1, we have all potential energy and no kinetic energy, and at point 2, we have potential energy and kinetic energy. Potential energy is equal to mgh, which is mass times gravity times height, and same with point 2, we have mgh because we have potential and kinetic. Kinetic is 1/2 mv squared, which is 1/2 times the mass of the car times velocity. The m's cancel out because in the end they will all cancel out because they'll equal 0. Gravity is 9.8 meters per second squared. Height of the first hill is 0.762 meters. Again, we have gravity for potential energy, which is 9.8 meters per second squared, and the height of the second hill is 0.1905 meters, plus the 1/2 mv squared for kinetic energy. Multiplying these together, we have 7.4676 meters squared per second squared, and on point 2, we have 1.8669 meters squared per second squared, plus the 1/2 mv squared. If we subtract the 1.8669 over to the left side, we have 5.6007 meters squared per second squared equals the 1/2 mv squared. Multiply by 2 to get rid of the 1/2 to equal 11.2014 meters squared per second squared equals velocity squared. If we square root to get v, we get 3.347 meters per second.
Mechanical energy at point 1 equals mechanical energy at point 3. Mechanical energy equals potential energy plus kinetic energy. There you go. Potential energy, there is potential energy at point 1, but no kinetic energy. There's no potential energy at point 3, but there is kinetic energy. Potential energy is mass times gravity times height, which is equal to kinetic energy, which is 1/2 mv squared. the m's cancel out, and you're left with gravity, which is 9.8 meters per second, and the height of 0.1, which is 0.762 meters, which is equal to 1/2 velocity squared. If you multiply these together, you get 7.4676 meters squared per second squared, which is equal to 1/2 velocity squared. If you times this side by 2 to cancel out the 1/2, you get 14.9352 meters squared per second squared. To find v, you must square root, and v equals 3.865 meters per second squared of 0.3.
The velocity of the car will be less than what we calculated because of outside forces such as friction and air resistance. The car has a displacement of 0 meters when it first comes into view. Over 0.13 seconds, the car travels 0.1016 meters.
Today is gonna be the day that they're gonna throw it back to you. By now you should have somehow realized what you gotta do. I don't believe that anybody feels the way I do about you now. Backbeat, the word is on the street that the fire in your heart is out.